Now for this, the first half of the unit, it's about circle and ellipses. And the way I'm going to put it is this. It's whether you know it or you don't. Okay. There is no get around. There's no shortcut. So if I say, do you know the equation of a circle? And if you cannot write it, then that's nothing else we can do. So, so the equation of a circle is x minus h squared plus y minus k squared is equal to r squared. And h and k stands for the center, and r stands for the radius. Now, and I also make sure that you are aware of the easiest mistake possible. For example, if I write down this equation, can you tell me the center? It will be -3 and +2. And what would be the most common mistake for people who did not study? They would say 3 and -2. So if you can tell what is the common mistake that people would make when they try to extract the center from the equation, if you know that, that means you are good. That means you are not going to be the person who would make that mistake. Okay. All right. So, so that's that. Right. So circle, radius, very simple. And then we have ellipses. We have a horizontal ellipse. And we also have, oops, let me orient the ellipse well. And we have a vertical ellipse. Okay, so for horizontal ellipse, the equation is, well, it's very similar to the one that it's very similar to the circle equation, because you still have the x minus h squared plus y minus k squared. The difference is that it's not equal to r squared anymore. It's actually equal to 1. Okay, if it's horizontal, that means the a squared would be positioned underneath the x. Okay, and then the b squared will be underneath the y. And if it is the vertical ellipse, then everything will be swapped. Oops, sorry, x minus h squared, y minus k squared. The a squared will be underneath the y. Okay, like this. And like I said, I need you to label the diagrams here, label the ellipses here. So so this is the major axis. This is the minor axis. Now, what I discovered is this: a lot of students, some students, not a lot, like some students, when they try to think of the A, B, and C, they are making it too simple. They are not using a complete sentence to describe what A, B, and C are. So what is A? Well, A is the distance from the center to the endpoint of the major axis. Okay? Use a complete sentence. Because some students, they would just say, oh, A, major axis. And they then, when they actually need to write an equation, they see, oh, something with the major axis, then they don't know whether it's A or 2A, or they just got confused. Make sure you are using a complete sentence to describe what it is. B, it's from center to the endpoint of the minor axis. Okay? And C, it's where? From the center to the focus, right? Now, that's a C. And what is the relationship between A, B, and C? C squared is equal to A squared minus B squared, or we can do the square root form. C squared is equal to square root of A squared minus B squared. I like this one better. I mean, you should be capable of finding out what C is if they give you A and B. All right, so we do the same thing for the vertical ellipse. We draw the major axis and the minor axis. So this is the A, this is the B. And if you are going to just hypothetically draw the focus, foci, then the center to focus distance would be C. Okay. A couple more things that are not shown on this diagram, but you must know it's something called eccentricity. E, it's equal to C over A. Okay. E is equal to C over A, and if E is equal to 0, it's a circle. Okay, so the hint, it's right there, or the answer is right there. If E is equal to 0, it's a circle. Okay, and E could be as great as 1. Okay, if it's a 1, that means it's a really long stretched ellipse. So if you somehow get an eccentricity of bigger than 1, then you know something is way off. Okay. All right, and that's one more thing. There's something called the lattice rectum. Now, if you don't know how to draw it, you can go ahead and draw it. Again, lattice rectum is the line that cuts through the focus and being perpendicular to the major axis. And that is the lattice rectum. Okay, and the length. Now, you will compute the length of lattice rectum. Okay, so yeah, the length of lattice rectum is 2b squared over A. Okay. It's a feature. Now, I would say it's not so, is it useful here? I mean, the lattice rectum, it's, what is it for? I have no idea. Yeah. Because in terms of, like yesterday, we showed you some pictures of like satellites. I don't see how lattice rectum it's relevant to those satellites. So I would say, yeah, I don't know. It's just a feature that's somewhat important. But for ellipses, we don't really talk so much about lattice rectum. We will, however, talk more about lattice rectum when we talk about parabolas next week. Okay, but for here, not so much. Not so much. So this is your cheat sheet. You know it. I wish you good luck tomorrow. You don't know it? Know it. Okay. Well, now that's a good point. Okay. Should you know those things like H plus or minus C or something? Now, I would say no. You don't need to memorize those because those are going to be very confusing. If you have a diagram, then you know whether you would add or subtract the X values or X value or Y value. Okay, if you know, and also capture these two diagrams, especially the fact that where do you find the foci? On which axis do you find the foci? It's always the major, long one. Okay, always. Okay, so if you know the orientation, then you know which one to add, which one to subtract. Okay, so for example, if you have a horizontal ellipse, then you know the foci, the center, they are all at the same y value. So that means if you need to find out the x value, you would just add or subtract c from the x value of the center. Okay, so just use the diagram to do the computation needed. You do not need to memorize that, oh yeah, let's label everything. You can generate those points from the drawing. So that's why I would say if you know how to draw, you know all these info, you should be in very good shape.